This is Britt Caswell with another example video. In this video, I'm covering example 1 from section 4-2 in the SavvasRealize Algebra 1 textbook. So this example is looking at solving systems of equations using substitution. So this is how to get an exact solution as opposed to graphing, which gives us approximates. So the idea of substitution is that we are replacing things. So when we have a substitution situation, you want to have an equation where one of the variables is by itself. So I could have y equals something, or I could have x equals something. So as long as a variable is alone, you're good to go. And so what I can do is wherever the letter y is, I can replace it with 6x plus 7. So here we are. I have this red equation. There's a y in there. So I'm going to rewrite this red equation exactly how it is, except where the y is, I'm going to leave a space, because instead of writing the letter y, I'm going to substitute 6x plus 7 there. Now it is important to note, whenever you do substitute, you must use parentheses around the term, because otherwise I would just be multiplying the 8 times the 6x, but the 8 needs to be times that 7 as well. So make sure that you're using parentheses. So now that we've done that, I'm going to go ahead and distribute the 8 to each term here. So negative 8 times 6x is negative 48x, and negative 8 times 7 is negative 56. But don't forget, the rest of the equation's still here, so I still have a 3x, and it still equals 4. So now I'm going to collect my like terms. So here, the 3x and the negative 48x turns into negative 45x. I still have my minus 56, and I still have equals 4. So now, to get the 56 to the other side of the equation, I'm going to add 56 to each side. So I get negative 45x is equal to 60. And then I'm going to divide by negative 45 to isolate x. So here a positive divided by a negative is a negative. And 60 and 45, those are both divisible by 15 if I think about a clock. And so I get 4/3 for my x value. So once I know what x is, I can come back to either of these equations and I could plug in the x to find my y. Alright, I could do either the blue equation or the red equation. In this case, I'm going to do the blue equation because y is already alone, and that looks like less work for me. So I have y equals 6 times negative 4/3 plus 7. Oh, that y looks like a g. Let me see if I can fix that. Alright, so 6 times negative 4/3, I'm going to have a negative number. Here, the 6 and the 3 cancel out, leaving me with a 2, so 2 times 4 is 8, plus 7. So my y value is negative 1. Now remember, our answers for these are where two lines intersect, or two lines cross. So it's a point on a coordinate plane. So I need to make sure that when I write this answer down, that I'm writing it as an ordered pair. Alright, let's go ahead and let's try another one. So on this one, my blue equation, it says that x is equal to y plus 6. So where where x is on the other equation, I'm going to replace it with y plus 6 right there. So here we go. Here's my orange equation. I'm going to leave space where the x is, put plus y is equal to 10. And remember, when you substitute, you need to make sure that you always plug in with parentheses. So that x is now y plus 6. So now I'm going to collect my like terms. I have y and y. Together that makes 2y. Plus 6 is equal to 10. So I'm going to subtract 6 from each side. So I get 2y is equal to 4. And then if I divide by 2, I get y is equal to 2. So now to find x, I'm going to plug y into either one of my equations. I'm going to plug it into this bluish purple one, just because x is already alone. So I have x is equal to my y, which is 2, plus 6. Now notice it's also good practice when I'm just plugging in numbers to put the parentheses. I don't necessarily need it for this one. But sometimes if you have like a negative and it's multiplied by stuff, it's really good to make sure you're always using those parentheses. So there we go. So 2 plus 6 gives me an 8 for x. So my final solution is the ordered pair 8, 2. So I could have graphed this one and gotten an exact solution, but I think that substitution's a bit easier than graphing because it's faster, honestly, for me. Alright, now another one. I have this brown equation where y is already alone. So in the second equation where there's a y, I'm going to replace it with 2x minus 1. I'm going to substitute that in there. So I'm going to write out the blue equation, but where the y is, I'm going to leave a space because I know I'm going to plug in there an expression. And then I use parentheses and put my 2x minus 1 there. Alright, so then remember, next we distribute. So 3 times 2x is 6x, and 3 times negative 1 is negative 3. So I have 2x plus 6x minus 3 is equal to negative 7. So now I collect my like terms. 2x and 6x makes 8x. Minus 3 is equal to negative 7. So then I'm going to add 3 to each side to get rid of that subtraction. And I get 8x equals negative 4. And then I divide by 8, and I get x equals negative 1/2 if you reduce that fraction. And again, I could plug into either the brown or the blue equation. I'm going to do brown. So I have y equals 2 times negative 1/2, which is what we got for x, minus 1. So a positive times a negative is going to give me a negative, and half of 2 is 1. So I have negative 1 minus 1, which is negative 2. So my final solution is the ordered pair, negative 1/2, negative 2. So there we have it. That is how to use substitution in order to solve a system of equations. Until next time.